Can you hear me?
Yes.
You can hear me? Okay, good, good, good. How are you doing?
Wonderful.
Good.
Professor,
Fine, thank you.
I have a question.
Yes, go ahead.
For our classwork 6 is due tomorrow.
Hmm.
I don't, are we using the bell shape for that? Because I don't
Class,
know if we're supposed
what's
to
the
be using the
classwork
bell
number
shape.
again?
6.
6. Give me a minute. Let me see which one you are referring to. Um, Assignments, classwork 6. Yes, you gotta use that for that.
We're using the bell shape.
Yeah, the same thing we did yesterday. You draw the graph,
Right.
find their z and so on. Yes, of course.
Right. Yeah, I just only wanted to make sure because I wasn't sure which one we were supposed to be doing. All right.
Yep,
Thank you.
you're welcome. Now I want to show you something there so that next time, say, look, the question says assume let's see, or if you say assume that it's normal, or you say it's having a normal distribution. See,
Uh-huh.
that's how you know
Yes.
you're gonna use it. Okay.
Oh, okay.
Hmm. All right, let's begin. Um, Tonight we continue from where we stopped. This is one I say practice do by the okay. This is the last one we did last night from we left.
You know what? You
Now,
didn't download it either because I
hmm?
didn't see it. Did you download it yesterday?
I
Because I
uploaded
didn't
it.
see it.
Yes. Yeah. This
I
can
didn't
you
see
see? Can
it.
you see my screen?
Yes.
Yeah, it's the one we did yesterday. The one we put finish in Excel, and I put the answers here. So I uploaded it. You have to look at it for under confidence intervals. That's why you got.
Oh, that's what it's under.
Mm. So now sample size computation. So we need to like I explained at the beginning of this class. Most time we'll be dealing with samples because we can't do census all the time. Census is expensive and the chance of committing error is high, and sometimes it may not even be possible uh, to do the census. For example, if a an automobile manufacturing company uh, that want to do a collision test, you cannot crash all your cars because you are trying to do collision tests. That would be brutal to the company. So sometimes it may not even be possible to do the sensors. So in most cases, we're doing a sample. We select the sample the right way, and then use the sample to make general conclusion about the population. So how do you know that select the correct sample size? That's what we'll be starting tonight. And this is the formula for that. Z alpha over 2, which you already know, is the critical value times standard deviation divided by the error, then square your result. Your answer, you round it up to the next whole number. Let us see how this works. At least I think one example should be good. It's very easy. Look at this question here. I'll make it 16. It says, um, the it is desired. Good. It is desired to estimate the mean number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within two chips with 98% confidence? The standard deviation is 10.1 chips. So the first thing you do is to list the numbers that you need to calculate here. Solution here, you can see that it says here that it is desired to estimate the number of chocolate chips per cookie for a large national brand. How many cookies will have to be sampled? So so it's made the true mean number of chips per cookie within 2 chips with 98% confidence. Now within say within 2 chips. So if there's going to be error, it will affect only 2 chips. Okay, two cookies. Now so that means our error is 2. And we are told that the standard deviation is 10.1. Now they give us the confidence level 98. So we need to find this the z alpha over 2. Z alpha over 2. Let me see if I can put this down a little bit. And insert alpha over 2. Okay. Alpha over 2 equals for 98%. Now, if it is given, we pick it from there. If it's not given, we calculate it by ourselves using the formula I showed you yesterday. Now, let's see if they have it there for 98%. So we have it here, and it is 2.33. Now, remember, if it is not there, we use this formula here to calculate it. But it's here, 2.33. So we have 2.33. 2.33. Okay. Now, with that, we are ready to do our plug all these numbers into this formula, and we'll get our answer. So minimum sample size n becomes, now let me write this down, and then I will take you to the page where we can put them in the formula. Delta is 10.1, and then z alpha over 2 is 2.33. So I'll take you where we can put this on the formula so we can get the results. So that page, I want to share it, our other workbook. Now we can put this in equation. So now, which means minimum sample size n. Okay, now maybe we plug in all those numbers equals. Please, those sending text, if you want to ask question, ask question. I don't text while in the class. So we have this. Put numbers in. This. Okay, we have it. We have I think I need to put something first. Okay. Then put more. See if this will encircle it. Good, I got it. So we have z alpha over 2 as 2.33. My computer is okay. 2.33. Okay, times standard deviation of 10.1. Divided by error of 2 squared. And when we plug this into the calculator in our we get our results 2.33. So I'll take you to the calculator so we can get our answer from that. I have 2.33 2.33 0.33. Okay, and the 2. Now we need the error at the top. Okay, times standard deviation of 10.1. 0.1. Okay, and then square it. You're 138.45. Write it down. 138.45. So we'll go to our workbook. 138.45, which gives us 139 samples. That's what we need. 139 samples. So I'm going to copy this and paste it in our main workbook so that we get our results. 139 samples. The main workbook is right here. So we have answered this question. So we need, because it was saying how many cookies. So we need 139 cookies. See? Or 139 samples of cookies. Any question on this? Any question?
No.
Yeah. So that's how we solve this type. You might try this one as a practice at home. Now I want you to notice something. You know, in algebra, when you run this, you're gonna be 138, really, right? In algebra, because this 4 is not up to 5. But what you're doing here is rounding up. So long as you have a decimal, round up to the next whole number. So it's not like the normal rounding. Just go straight to the next whole number. Now, like I said, you can try this or this and say practice for your own practice. Now let's look at next type of confidence interval for the mean. The one we just did, we finished yesterday. For that one is case 1, where the standard deviation is known and the sample size is greater than 30. That means you have a large sample. But next, the one we'll be looking at next is the confidence interval that have a small sample. You have sample size, the population standard deviation is unknown, and the sample size is small, less than 30. For this, we use a table that is called the student t distribution table. Let me show you the table. Remember, I say print the statistical tables. I believe I mentioned it many times. Now, where is my table? So I'm going to close some pages so that we can have enough room here. Okay. Now let's see if you can see it. Statistical table. There's still something that I need to close this. I need to close this. Close this. Okay. Let me there. All right, let me see. All right, let's see. One more thing we need to close. So I'm looking for my statistical table. I can't see it. And I opened it, I'm very sure. Okay, let me look it outside from here. Okay. All right, it's right here. Now I can share it with you. Can you see it?
Yeah.
Now, this is one we use for large sample. The one we're using now is this one. It is called the student t distribution. Let me make it bigger. Okay. See, student t distribution. And we use it when the sample size is small, as you can see from here. For n is small, less than 30, and the population standard deviation delta is unknown. So this table is based on sample size and what we call the degree of freedom. And they get the degree of freedom by doing n minus 1. That is sample size minus 1. Let me show you how to use it. First of all, then after that we can then use it to calculate the confidence interval for the mean for a small sample. For that, instead of using z alpha over 2, we'll be using t alpha over 2 because it is the student t distribution, not z table this time. So instead of using z alpha over 2 for the critical value, we'll be using t alpha over 2. As you can see from here, say t alpha over 2, make it bold. See, now it says, let's do 2 examples on how to use it. The equation says, find t alpha over 2 value for the following confidence levels. You can see this, right?
Yes.
Okay. Now, it says for the first one is for 95% confidence level, where n, which is n represent the sample size, is 22. As you can see, the sample size is small, 22. 99% confidence level, where n is 10, and 90% confidence level, where n is 14. Now, I'm going to do these first two. You can practice with the last one. So now, for the first one, you have a 95% confidence level. If you're 95% confident, that means if you're 95% sure, your chance of being wrong is 5%, right? Or wrong? If you're 95% sure, that means your chance of being wrong is 5%. Am I right?
Yes.
So
Yes.
that means that your alpha will be 5%. Well, that means 0.05. And the sample size is 22. So write 22. Degree of freedom, like I mentioned, the formula is dn minus 1. So that means 22 minus 1, which is 21. Now you can find the critical value, t alpha over 2. To find that, your degree of freedom is 21, and your alpha is 0.05. Remember, confidence interval is two sides, like we did last night, the lower side and the upper side. So when you go to the table, you'll be looking for alpha that has 2, confidence level of 2. Let me show you what I mean by that. When we look at the table, you can see that this have a confidence level. You see, this one A with 1 prime. But because we are doing confidence interval, we'll be using this one because it has double prime, which means 2 sides. So for this particular question, our alpha is 0.05 and our degree of freedom is 21. So that when we go to the table, looking at alpha, see, look at it here, 0.05 is right here. See? And then degree of freedom is DF. You go under 21. See? So 0.05 under 21 is this one here. See, 21 here. And 0.05 is 2.080. Okay? 2.080. So that's how to find the critical value with this type of table. Now let's try the second one for 99%. If you're 99% confident, your chance of being wrong is 1%. So your alpha is 1% or 0.01. The sample size for this one is 10. You got 10. So the degree of freedom is n minus 1, which means 10 minus 1 is 9. Okay. Now let's go to the table and look for under alpha of 0.01 with 9 degrees of freedom. We go to the table. Remember to go to the one that have 8 with double prime. 0.01 is this one here. Not this. This one is 0.1. 0.01. Under 9 degrees of freedom, right? Look at degree of freedom, and this is the 9 degree of freedom. So if you follow it, you can see that the answer is right here. Okay. 3.250. Okay, 3.250. So that's how to use the table. When you have the chance, you can try this one, and you can always watch this video so as a guide. Now let's apply this. Remember, this is for confidence interval for the mean when the standard deviation is not known and the sample size is less than 30. So let's try this example here. It says a sample of 6 college wrestlers has an average weight of 276 pounds with a standard deviation of 12 pounds. Find the 90% confidence interval for the mean through mean weight of the wrestlers. If the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? The first thing you notice on this question is that your N is 6, which is less than 30. So this is a good candidate for the T table. So our N equals 6. Okay, and then the weight sample mean is 276 pounds. So this page will not allow you to use that character of x bar. So I'm gonna write x bar 276 pounds. Let's go and get it from that other workbook and then paste it here. X bar we have this a little bit. I can see, oh, I see. Insert X bar. Let's see. Okay, the equation. So we have this is my I'm gonna take this down. Okay, equation X bar. Good. You can get it from here. X bar so here equals 276 pounds. So I'm gonna copy it from here and then paste it in our main workbook. Okay, I'm gonna put it here. Our main workbook's right here. Okay. Now, next thing is the standard deviation is 12 pounds. That one I can get from here. Standard deviation is 12 pounds. Okay, I think it's not it. Let me get the formula, the symbol from the other page. Standard deviation is equal. Okay, the symbol from here. That's fast. That's faster. So get as 12 pounds. Just like we did last night, just list the numbers and then you can just get your error margin. Now, we are looking for 90% confidence level interval. So let's see for the critical value for 90%. Now, we're not using Z alpha over 2 this time. We're using T alpha over 2, T alpha over 2 for the table. Before you can get that, let's see. We have an N. We need the degree of freedom, like you have here, degree of freedom, N minus 1. So, degree of freedom, df, equals N minus 1, which means 6 minus 1. And that will give us 5. And our alpha is, it says 90% confidence. So alpha, our chance of being wrong is 10%. So that our alpha is 10%. Equals 10%, I mean 0.10. So that the critical value becomes T alpha over 2, T alpha over 2, because it's 2 sides. Remember from last night, it's 2 sides, lower side and upper side. So T alpha over 2, we look under the table for degree of freedom 5 and alpha of 0.10. So we go to table of the student T distribution table. Under this A double prime, you can see the alpha of 10 right here. Now you go under 5 degree of freedom. You can see 5 right there. DF 5 and the alpha of 1.1. So that gives us T alpha over 2 of 2.015. With this, we can now put it here in our list of number we need to calculate the error. 2.015. Now let's find the error margin. If you remember the formula for error margin, I think I have it here for you. We used it last night. The formula for error is right here. So I'm gonna put it here. Z alpha over 2 times standard deviation over square root of n. That's the formula. So I'm gonna put it in our other workbook so it will allow me to put it there, and then I can copy it and paste it here. So taking you to that workbook, we have error. So instead of using Z alpha over 2, this time we're using T alpha over 2, T, excuse me, T alpha over 2. Our alpha is somewhere. Okay, gonna be right. Alpha over 2. Okay, times, excuse me, go up. times standard deviation. This time we use sample. The other one we use population standard deviation, but this time we're using sample standard deviation because it's a small sample. Just put standard deviation over root n. Standard deviation will be all of them are sample anyway. But we don't know the population standard deviation, so we are using sample standard deviation. Unlike the other one where we know the population standard deviation and the sample size is large. For the square root of n, okay, which give us t alpha over 2. Now, let me go to that other page so we can get these numbers. Now write them down. Our t alpha over 2 is you can see right here is 2.015. And standard deviation is, they tell us that it is 12. N is, you can see right here is 6. So now we can go and put them in that formula, get the answer, and then move it to our main workbook. So for t alpha over 2, we have 2.015. Okay, times standard deviation of 12 divided by the square root of n, square root of 6. Okay, let me write it down so we can get it from the calculator. 2.015 times 12 over square root of 6. Okay, now we can get it from the calculator, online calculator. So we have 2.015 times standard deviation, which is 12 divided by square root of 6. Okay, now we have it right here. 9.87. Okay, so we go back. 9.87, put it in our workbook, and then move it 9.87. Okay, so I'm gonna copy it. So basically, it is getting the error margin, then you subtract the error on the left side, and then add it on the right side, like we did last night. Okay. Now we have everything we need. Now we can say the 90% confidence interval is x bar minus error less than mean. This is what the mean we're trying to estimate. Less than s bar plus error. So that means our s bar is our sample mean, which is 276. Okay, 276 minus our error of 9.87, and less than, okay, the mean. I can get the mean from here. Okay, less than something, repeat the something, mean of that s bar plus error. So s bar is again 276. 76 plus the error of 9.87. So as you can see, you just get the error first of all using all these numbers. Okay, then subtract the error on the left side and add it on the right side. That will give you the confidence interval. Okay, which means that I will have 276 minus 9.87. Let's go and put it in the calculator. We got okay, 276.
266.13.
Is that the answer you got?
Yes.
Let's see. Yes, 266.13, correct. And when you add it, what you get? So when we change this to addition for the right side, to plus, we get 285.87, right?
285.87. Yeah.
285.87. So let's go and put it in our workbook. So for the left side, we have 266 0.13 pounds less than, so I'm going to copy this. Okay. So this less than, we have 285.87. So that means the average weight, when you say find the 90% confidence interval for the true mean weight of all wrestlers. So the average weight for all wrestlers lie between 266.13 and 285.87. So we can now conclude. Conclusion. Okay. We are 90%, because this is 90% confident that the true or average weight, average mean also mean average weight of all wrestlers lies between 266.13 pounds, 0.13 pounds to 285.87 pounds, 285.87 pounds. Okay, of course this is based on a sample of 6 wrestlers. So that's what it said. Find the confidence in 90% confidence interval. That's the 90% confidence interval right there. Okay, and this is our conclusion right there. Any question on this before we do part B? Okay, good. No question. Good. Part B says, if a coach claimed that the average weight of wrestlers on the team was 310 pounds, would this claim be believable? Of course, it won't, because 310 pounds is bigger. It does not fall in this interval. See? So
Yeah.
part B. So part B means no. B. Say would the claim be believable?
No.
So it won't, right?
Right.
No. The claim will not be believable. Not be believable because 310 pounds falls outside the confidence interval. So let me save this because I'm gonna upload this for you after. Okay. Now that is it. That's how to get confidence interval for small samples. You know. Now this type here is the same thing. All you gotta do is to find the mean. In this one, they give you the mean of 206 pounds, and they give you the standard deviation. And this one, they didn't give you the mean; they just give you the numbers. So how many of them? 1, 2, 3, 4, 5, 6, 7. So that your n is equals 7, right?
Yeah.
So to answer this, remember I showed you how to get the mean at the beginning of this class. I also showed you how to get the mean and standard deviation using
The largest to the
X.
small.
Yeah, or that one is range. Mean, there's a formula for mean, or you can get it from using Excel. So you find your mean X bar, you can find your X bar sample mean. You find it. I'm saying you can try practice that. Use that as a process. You can use the formula method, or you can use Excel. Type these numbers in Excel. Find the mean. Find the standard deviation, sample standard deviation this time. Remember there's a formula for standard deviation, symbol, delta. That one is for population standard deviation, but here, we don't know the population standard deviation. Remember, this is where we don't know it. See, delta is unknown. So we're using S to represent sample standard deviation. So once you type this in Excel, get your mean, get a standard deviation, and then use get a degree of freedom, excuse me, df equals n minus 1, like we did, which is 7 minus 1, and that gives you 6, right? Now, then you go to your table to find the t. Listen, keep giving me capital D. Get your t alpha over 2, t alpha over 2. Right, insert this alpha over 2, like we did in the other one, equals. Now you go to the table and look for this. It says 99%, right? So I'm going to get all these values for you, then leave it for you to get the mean and standard deviation by yourself, and then finish it by as a practice. T alpha over 2, which is since we have a degree of freedom is 6, and the alpha is, let me put alpha first. Alpha for 99%, alpha is that means 0.01. This is 99%. So that T alpha over 2 from the table is under 0.01 is right here. You go under 6. See this degree of freedom of 6. Okay. So 3.707, right? 3.707. 3.707. So I have got everything for you on this. Now go and get your standard mean and standard deviation using Excel. Type this in Excel and find it, and then find your error margin. Error equals, find it by yourself, as a practice. Then get the confidence interval and conclude. See if you can do that by yourself following the method I explained here, and then you can finish it up as a practice. Any question before, because we have only 2 minutes, we have less than actually 2 minutes left. We can't do much on that, so I'm gonna time us out. But before I do, any question before I time us out? Okay. In that case, I will time us out. So please wait for 10 minutes, log back in. Let us begin test of hypothesis. We are not going to do confidence interval proportion. So when we come back, we start begin our test of hypothesis. Okay.
Right.
So I see you back here in 10 minutes. Yeah.
All right.
Okay.
Okay. Bye.